Christoffel symbol. You know, like I said, sometimes that's rabbit calc. I have a town, Christoffel. Who's ever named? Bell's equality, inequality, or Copenhagen. You got what's his name? Inequality or exclusionary. Like I said, you snatched up a kid that day that was getting ready to come around Skull Mountain on this draw out that was drunk, 18, 30, fucking having problems, doing all kinds of shit. It all makes the same number.
Now proceed to part 3, the Christoffel symbols. Now you'll remember that I said that the important thing about tensors was that they represent a fixed relationship between two vectors, and they are independent of a coordinate system. In particular, if one tensor is 0 in one coordinate system, it will be 0 in all coordinate systems. So let's suppose that we have a tensor, let's call it W.
I'm not going to give you any other tensor metric. You can stick with FMA if you're not a mathematician. And I only need one. I'm not going to try to show off some fancy shit about.
Also with n and m coordinates in the x frame of reference. If that is true in the x frame of reference, it must be true in all frames of reference. To take my example of the field right at the beginning, if the height of the field is 2 meters, it matters not what frame of reference you're talking about. It will always be 2 meters.
No, you'll fight them. You'll kick each other. You'll
but here's the problem.
Yeah, no.
The problem is that the derivatives of tensors do
Too
not
fast.
necessarily
What I like to say when I'm doing that is when I'm getting going.
Frames of reference, and we're going to need derivatives of
I could
tensors.
know all
so
this,
we need
but
to
what
know
makes
what goes wrong.
This twister
So
theory.
let's take a tensor in the x frame of reference.
Fundamental
which
analysis
we'll call
or functional analysis, just some A's. I'm going to give you X, Y, and Z, limitless, a few different field types that really doesn't tell you. You're going to use this type of equipment for rabbit.
With respect to n,
but what it means is billy goat around here.
Now the question is,
that form
does
of
that same tensor in the
it's
y
going to be
frame
energy, electricity, and some stuff in a common field where we're going to get into the chemistry. We'll see multiple equal arrows that are greater than and some weird fancy horse shit that goes into
the y frame
and
of reference.
or
Is that true?
Nor
and the answer
and not.
is no, sadly, and we'll find out why. I'm going back to equation 5, which should appear on the screen, but I'm just going to rewrite it exactly as it was.
So you get into all kinds of up, down, left, right. What is up? This is what is up. This is, I'm looking at it when it's down. I'm looking at it when the spin direction on it is something very specific, so I can set that off in a beaker. And I want it to do a certain test, or I might do singular sets of tests that
was just
height, matrix, differential, and that's a rocket science equation right there, setting up the balls in the beaker for Murphy. Some kid that is a photon to me, or an apple, and I might figure out in the Hadron Collider what that turns into. And here's, you know, some of the photon, gamma,
well, let's just rewrite that.
gluon, boson, W boson, WM, and we'll switch off real quick, but what they share in common with types of math is you'll see them all in the same position to T.
dyn, but instead
that's what this matrix will help you do. It helps me grid off
I'm going to write
what I really want scaled off inside of what here's the black body problem. There's a lot of
so this now becomes from the equation above dV
Bekenstein bounds on
divided by, or as it
this
were,
Frankenstein-Bernoulli's equation of Fermilab's experiments.
I've simply written TRS
for
in this form here.
This rabbit with an axion of, well, I'm doing it from here because n
now,
1/2. See what you did real fast. Click into a frame. And into a frame. There was 3. There was this frame, there was the move of the frame, there was the click of the frame. And at any 2 points in time inside of there, it was that original set. But somebody would have been like, you fucked that up a little bit. Did he?
Trap this, so it simply becomes
There's going to be a twister theory, man. Pendrell, this is one of the big beasts out there running the Z limits on backwards, forwards. It's a reverse engineering trick of looking at it from knowing the math first
this term
and then
here,
applying that to
dxr
actually
by
break it down backwards,
dym
forwards, inside out,
times this
upside down
contracted,
chess
which
game,
is just dvr
you're going to call
by
me
dy.
on, well, how does
So
the
this is
irrational
dvr
value of this
in
set
the
into the
x frame of
system? Well,
reference
it's a real Bernoulli's equation.
by
That Bernoulli
dy
value
dy
inside here
n.
also has z limit. It has, I have to look at
And
it
the
from the
question we
house,
want
this
to
limit,
ask
this set
is,
right here, this system, the set
does
of derivative
that
x squared, derivative x number, on what the
dvm
house shapes were, how high
dyn
off the hill,
in the
what
y frame of
variable
reference.
on
So
what he did
does it
back
equal-
before about running some numbers
question
on
mark,
that hill,
does it equal, because we don't know whether it does,
being some of the
dvm
values that give it internal
in the y
mass
frame of
by
reference
photon value,
by
well,
dy
sending it
n.
down the pipes in some of these diagrams,
Well,
or
what
and
is
or nor not
this
gates
term dvm
about
by
logic on the motion,
dyn?
speed, position of
Let's
things,
just
and where
write
they're
that
supposed to
out.
be, about
dvm
the black body
by
principles in the
dyn.
chemistry,
I'm
physical,
going to use
engineering,
equation
shear forces,
5,
time
which is actually
dilation
a
models
tensor
of
term, but
understanding the
remember, tensors
chemistry
you
to
can
actually
reduce to
do
vectors
it
just
in a
by
way
dropping
that's
one of the,
beneficial,
indices,
because I know I
and
need
if you just
steel,
do it for
and
a
it needs to be a
single
length,
index,
but I have to
then you
change
can
the
see
length
that
of the steel
dy
in a composition problem to
dvm
equal
by
in the same
dyn
system that services
actually equal
what is
to
logically
the
the system. If it's raining for
derivative
hydromonium
of,
outside on Venus, clearly
with respect
gravity
to
is different.
yn of dxr
Now,
by dy
back to those
m
compositions in physics.
times vr
The red,
in
this is
the
the
x
red.
frame of reference.
Some things
That
are
is
going to come
what
up often
dvm by
on some of the
dyn is.
key
If you take it
cicada
from
values that actually is necessary to
equation
fill
number
this stuff up.
5, but
And
looking at
form
it only
can
with
come
one
in many
index.
sets to applications,
But
resumes,
this is a
tools,
differentiation
overtures,
of a
and
product.
values, the Homer-Simpson
And you should know that if
nuclear
you
fusion power
differentiate a
plant
product,
over here
let's
to the names, the
differentiate A
institutions,
times
the
B,
banker.
then the differential of a product will be
And that's
A
going to be
times
yours.
dB
And it's going to be hard for the big
plus
man
B
up top to do anything.
times
And
dA.
understand
So
gravity
if this
is
is
the number
A
of
and
dimensions
this
of
is B, then the
electromagnetism.
differential of that, differential of AB will equal, so we've now got
I
the
don't know.
dVm
So I bet you if you did the list.
y by
I bet you if you did
dyn,
the
which is
S&P
this term
500
here,
the way it's supposed to
is
be,
equal to AdB, which is
it
dxr
would probably work
by
just
dyn
fine, boot barn.
times dB, which is
And you're gonna run some stock
dVr
models.
in the
You're
x
gonna build you
frame
some special
by
graphs inside of a year.
dyn.
It's a whole
That's
year right here.
dB.
And you just hammering on.
Plus B, which is VRX, which will stick out here,